So look, I don't know how many of you are fully fledged philosophers, so how much I need to explain. Let me just say this much. I hope you don't mind me using this one. My memory is terrible. So it helps me. So what I'm really interested in is certain kinds of experiences and a certain conception of experiences. I think it's the kind of background view is that experiences tell us about something. That's what I mean by represent. So, you know, if you have a belief, it's about something, yeah? It has a certain kind of content. So if you believe that something is hot, you're in a certain mental state which represents the world to be a certain way, yeah? And the idea is that one might think about experiences in the same way. So your experiences, the experiences that you have, represent the world to be a certain way. And what I'm trying to look at here is if something like that is the case, what is it that our experiences of heat and cold represent or tell us about? Exactly what it is that they're about. I mean, you might say, well, isn't it obvious? They're about hotness and coldness. I'm not so sure. I think that's not quite right. And what I'm going to do is give you a line of argument. So it might be kind of interesting. So next time you feel hot or you feel something that's hot or cold, you might think, oh, actually, that's what's going on. I hadn't realised that. That's the kind of hope. The reason why I'm doing it is because there's very, very little literature on this. There's lots of stuff. If you're doing philosophy, perception, there's lots of stuff on visual experience, on colours and that kind of stuff. Loads of it. You know, that's what people will teach you in philosophy of perception. Very little on this, and I think this is distinctive. So it's worth thinking about. It also might give us certain clues about how perception works elsewhere, although I'm not going to go into that. So look, here's how, say my memory is terrible. I left my dongle elsewhere, so I can't do this remotely. I left it in some room in Cardiff somewhere, I haven't found out right. So look, the first thing you might think is, okay, so when you have an experience of heat or cold, you might think what's going on is you're representing properties of things. You might represent that something is hot or something is cold. So when I pick this up, I have a certain experience of a certain kind of cold. So one thought is, I'm representing with my perceptual experience that this bottle is cold. Similarly, if you put your hand on the hot cooker, your hand will feel a certain way. What's going on there? I think the typical thought is that you're feeling that the cooker is hot. I want to challenge that view. I don't think that is what's going on. One reason why you might think that what's going on when you have these kinds of experiences of heat and cold, that you're representing things to be hot or cold, is that this is typically how you come to know that things are hot or cold. And after all, I think it's right that we do believe that that is cold, the oven is hot, and I think it's right that things can be hot and cold. It's not quite clear what it is for something to be hot or cold, and I'm not really going to go into that, because I want to just challenge the view that when we have experiences of heat or cold, that's what's going on. In fact, what I think is going on is this. So this is the position that I'm trying to defend here. Not that heat sensations represent things to be hot or cold, but they represent energy being transferred to the body. That's heat sensations. And cold sensations represent thermal energy transmitted from the body. So I'm taking it that we all understand what a heat sensation is. I mean, I can light a match underneath your chin if you'd like to find out. But okay. And cold sensations, so I'm taking that as just read. We understand what that is by example. The question is what's going on when we're having these kinds of sensations. I think typically people think we're representing properties of things being hot or cold. I'm denying that. I'm saying, I'm challenging that. I'm saying something else is going on. I think this has this does have ramifications for other issues in the philosophy of perception, but I'm not going to go into that here. I think it tells us something about the nature of qualia, if you've ever heard of that, but I won't go into that here. All I'm interested in is just giving a picture of what's going on when we have these heat sensations and cold sensations that you might not have thought about before. But if you want to think further, I think this has ramifications. But I say I won't. So I'm going to call this heat exchange model, because we like names, we like to be associated with theories. So I guess what I'm advocating is a model of what's going on when we have heat and cold sensations, and trying to give you some reasons for thinking it's plausible. Both negative in the first half and positive in the second half. So the negative bit will be trying to show you that it's not properties of things that are being represented. The positive bit is to try and show you some reasons for why it is these processes that are being detected or represented by means of heat and cold sensations. So that's the way it goes. If it's right, it's kind of curious because it looks like heat, when we have experiences of cold, this is a form of heat perception. What's going on is that we are perceiving heat exchange. It's just that in the case of having a cold sensation, we are detecting the heat that's being transferred away from us. When we're having a hot sensation, it's the energy transferred to us that we're detecting or representing. So again, not properties of objects, but processes. That's the new move here. And if it's right, because most people think that what's going on in perception, visual perception, when we perceive colours of things, is we are detecting properties of objects. So it looks like it's something else. It's a different kind of metaphysical or ontological category of thing that's being represented in heat perception, a process, not a property. So I think that's one interesting feature. So, you might say, well, hang on, is this really right? Surely I find out whether this is cold by touching it and having a certain sensation. Surely I found out whether the hob is been on recently by touching it and finding out whether it's hot or cold. I mean, I think that's right. So be very careful what my proposal is. My proposal is this. We have beliefs that things are hot or cold. So we have beliefs that have a certain content, and that content is that things have certain properties. What I'm saying is experiences don't have that content. So right, we can believe that something is hot or cold, but our perceptual experience doesn't have that content. It tells us that energy is coming to and from. Does that make sense? So I'm kind of, I'm not sure how much you know about the kind of theoretical background in philosophy perception here, but there's a very popular view that says we represent things when we have perceptual experiences. That's the way to explain perceptual experiences. So I'm representing visually lots of colours and shapes in my surroundings. Yeah, sure. Yeah.
Is that intentionality?
Right. Yeah. Do interrupt. I mean, there's no point in me yabbering on if it's totally, I see there's nods, so people are getting certain things. But do stop me. Yeah. So that's the idea. The idea, right, is that experience is representational or intentional. It has a certain content. It's about something. So your visual experience is about colours and shapes and perhaps objects in some part of your visual field. What I'm arguing here, or proposing, that in case of heat perception, it's not properties that are being represented, it's processes. So it's a distinct, and that's all I'm interested in here, just this, motivating this view, that what goes on when we have a heat sensation or a cold sensation is that a process is being detected.
So is there a definition of a property independent of the process that it causes?
Right. I think that there is. I mean, I will go through what I take to be potential properties that might be represented by heat and cold sensations and argue that it's not plausibly those. I mean, I won't come up with a technical definition here. I'll just come up with some possibilities to show that that's not what's going on. That's the way to do it, I think. So this is what you've just suggested. So I'm thinking my conception of experience here is a kind of representationalist one or intentionalist one, as you said. It's one in which when something is represented in experience, when we represent something to be the case in experience, there's a kind of phenomenology to it. So when you represent a colour, for instance, somewhere in the room, there's a phenomenology associated with it, as of blueness, for instance. And I think the same is going on here. So when we represent something in experience, there's always a character to this. It has a phenomenology. Does that make sense? There's a, you know, what you might have got in your class is there's a what its likeness to experiences. And similarly, when an experience is about something, it has a certain phenomenology associated. So when you have an experience that's about a colour, there'll be a phenomenology associated. That's the kind of ballpark I'm interested in. Just the view that experiences have some kind of what its likeness, and they're about things. But all I'm interested in trying to motivate here is the view that when we have a heat sensation or a cold sensation, what it's about is a process, not a property of things. That's the claim. That's the one claim. Because, as I said, I think it's intuitively, most people think, oh yeah, when I'm having a sensation, it's telling me that something is hot. It's telling me that something is cold. They might not think very clearly about what it is for something to be hot that's being represented. And a story would have to be told about that. So that's my target. So here's the outline to get us going. I want to set up, as I say, that very, very, very little has been written on this. There were a couple of theories that were set out in the 70s, 60s and 70s. In fact, yeah, about 62, I think, around then. That explain, there's a certain duality that I want to point to that I think is going to be important, that needs explaining in any kind of theory of heat perception. So we'll do that first. And then I want to give a kind of line of argument, and it will be interesting to see how clear this is, because when I've given this elsewhere, some people say, oh yeah, that's obvious, yeah, that's right. Other people say, well, I can't get that. So it would be interesting to hear your feedback to see if it works. So the first bit, the negative bit of the paper, is a line of argument against the view that it's properties of things that are being represented by heat and cold sensations. Then I move on to the positive stuff, which is to give a couple of reasons for thinking it's these processes, inputs and outputs of energy, that's really being represented here. That's what our thermal reception system is doing. That's the point. And then I want to finish off, because I think this is quite important too, is to note a couple of consequences it might have. Do that very quickly, see what you think. So that's how it goes. Does that make sense so far? We all kind of on board. So look, here are the two theories. The two things, there do seem to be two things that need to be explained in a theory of heat perception. And again, I think this is distinctive. It certainly doesn't seem to apply with respect to visual experience, auditory experience. I don't think it quite applies in the same way to touch. So here are the two ways. We can feel part of our body being hot or cold, and we can feel other things being hot or cold. That seems to be intuitively correct. So we want an account of how this works, how it's possible for us to be able to do both these things. Vision just tells us about what's going on out there. Audition tells us what's going on out there. Touch may be when you touch something, does that tell you both about something about your body and the object you're touching? Maybe. But I think what's interesting about heat perception is we can feel parts of our body to be hot or cold, and also we can feel other things to be hot or cold. How does that work? These two theories that I will go through very briefly, and this is just to give you an idea of what's going on and what needs to be explained. The fact that there seem to be two different aspects to heat perception suggests that there might be two ways in which we feel heat of things. And this is what these two theories, I think, have suggested. I think this is wrong. I think we'll have to explain it in a different way, and I'll say how later. So I think that's a mistake. Here's, I think, an example. Sorry, but I got up there. But this is this is by someone called Beasy in the 1970s. It'll give you an idea of what's going on. And why I think this is important is because we need an explanation of this. So he says, and see if this makes sense, it's possible to distinguish between a person's perception of the heat of something and his feeling hot himself. So standing on the station platform, or outside the station waiting for the bus to come up here, which didn't arrive. Standing on the station platform in icy weather, one's feet are likely to feel cold. Yeah, does that make sense? So parts of your body can feel hot or cold. We need an explanation for that. But their feeling cold is not a matter of their feeling cold to one's hand. So the idea here is that a part of your body can feel something else to be hot or cold. And that's the thing. Although they might well do. With one's hand, one can feel the coldness of one's feet in the same way as on moving one's feet from a warm part of the bed to a cool part. One can, with one's feet, feel the coldness of the sheets. So the idea is simply this at the moment, that you can use parts of your body to feel whether things are hot or cold, including parts of your own body. Yeah. So, don't you worry, make yourself comfortable. So you'll have to play catch up, but I keep recapitulating usually, so it makes sense. So I think what this quote provides is some kind of data for what needs to be explained. It looks like what needs to be explained is two things: the way in which parts of our body can feel hot or cold, and the way in which other things can be felt to be hot or cold. And they are so felt by a part of our body. Yeah. So how is that best explained, and what does that tell us about what's going on when we have heat and cold sensations? That's the reason this is here. So this is some data that needs to be explained by any theory of heat perception. I'm using heat perception here to include both heat sensations and cold sensations, because in my view, heat perception is the detection of heat exchange, which is detected by heat and cold sensations, because heat is exchanged in two different ways. So so that's, are we all happy about that as some kind of primitive, some data that at least that any satisfactory account of heat and cold sensations has to do justice to? I've got a particular account of what I think is going on. As I say, I think in all these cases it's heat exchange that's going on. But I would still have to explain how there seem to be these two different sorts of perceivings. Perceiving your parts of your body to be hot or cold, and perceiving other things to be hot or cold. In fact, the trick's got to be, okay, so what's really going on when you feel a part of your body to be hot or cold? What's really going on when you feel an object to be hot or cold, or perhaps a part of your own body to be hot or cold with another part of your body? That's what we need an explanation for. And as I say, because I've already put it on the board, I think it's these processes, a bit more needs to be said. We okay so far? So here are the two theories, the only two theories as far as I can find in the literature on this stuff, and one of them is by someone called Godfrey Beasy, again from the 60s. This is from the 60s, I think. I mean, you might remember, I don't know, in first year you might have done a bit of John Locke or Berkeley. Locke has this primary, secondary quality distinction. So he thinks heat perception is a good example of secondary quality, but not much else has been written about it, really at all, since then. I think that account doesn't work anyway, but I will explain why in a minute. So Beasy's view is this. So remember, there are two kind of types of experience that we want to explain. The ones where part of your body feels hot or cold, and where another object feels hot or cold. That's the data. Beasy thinks it goes like this. And this might be useful just to think about if you're doing these kinds of courses, because if you mentioned intentional theories of perception, this is before those became popular. But it's just about the start of it, because the second view is really an intentionalist account. Beasy's is not. So it's kind of interesting, it's a bit of history of philosophy. If you are doing I don't know if you're interested in philosophy of perception, you're interested in the history of philosophy of perception. This is a stage in the 60s where the intentionalist accounts were just starting to become popular. So Vesey says this, look, there are two kinds of sensations. This is what's going on. So when you feel a part of your body to be hot or cold, it's because you have an intrinsic sensation. Okay, this is a bit of jargon, but what he means by this is it's just a sensation. It doesn't tell you anything. It's not representational. It's purely qualitative, if you like. That's what he means by an intrinsic sensation. Like a pain. People often think of pains as being intrinsically sensational. They don't tell you anything else. They're just a feeling. So he thinks that works for the case of feeling a part of your body to be hot or cold. You know, when your foot gets cold, what's going on? There's an intrinsic sensation there. But when you feel something to be hot or cold with a part of your body, that's constituted by a perceiving sensation, which would be intentional. So it tells you something. So that's the idea. When you feel that to be cold, it's because there's a perceiving sensation which tells you that's cold, according to this theory. When your foot feels cold, it's just because there's this intrinsic sensation. This is just a model, just to get things. This is a possible explanation for the data. That's Vesey's explanation. It's not mine. I don't think that's right. I think it's all representational, but representing something else. But that's his theory. The other one. So again, if you are interested in the history of philosophy of perception, Armstrong was one of the very first intentionalists or representationalists, and he said that, look, what's really going on is this: when a part of your body feels hot or cold, this is a kind of form of bodily perception. You are detecting a part of your body to be hot or cold. It's not that there's just merely an intrinsic sensation here. What's going on is that you have this perceptual system in your body which detects the way your body is, the properties it has. And in this case, it detects the heat of your body. That's his claim. So it's kind of it's distinct from the Vesey one. For Vesey, when your body feels hot or cold, there's just this intrinsic sensation. For Armstrong, when your body feels hot or cold, there's a system, there's a perceptual system, a bit like vision, a bit like pain, if you like. Because for someone like Armstrong, pain tells you something. It's a bodily perception of damage, perhaps. And something similar is going on here. Ooh, lovely there.
Maybe tap it to the next slide.
Oh, that's so clever. That is really clever. God, I wonder whether that works in Cardiff. I've never tried that. So he's explained. So he has a certain explanation for the one kind of sensations when you feel part of your body to be hot or cold. He also has an idea of how you feel, what's going on when you detect something else to be hot or cold. He calls this tactile perception of heat, and he thinks what's going on here is you are detecting the difference between the heat of your body and the heat of the other object. So when you feel something to be cold, according to him, you're detecting the difference in the heat of your body and that object. It's an interesting theory. I think it's got a problem. I think I've got a competing one that accounts for things better. So those are two theories, and I only present these to give you some idea of what needs to be done and how you might do it. So you've got this data, heat perception, feeling parts of your body to be hot or cold, and feeling other things to be hot or cold. Hopefully you're going to think about it from now onwards when what's going on here. I think the other thing why it's quite fun is because when you're doing philosophy, they tend to give you visual perception. It's quite hard to get your head around all the different possible accounts of visual perception. But I think it's that much more tractable when you come to this kind of perceptual modality, because I think it is a distinct perceptual modality. So those are the two possibilities. Which one do you think might work? I don't think either of them works. Here are some problems. So here's a problem for Vesey. Do there really seem to be distinct kinds of sensations? I don't think so. Think of these kinds of cases. I was on sabbatical in Crete writing this, so I was sitting on my, I suppose you could say, I was working out on my balcony, looking at the White Mountains in Crete. And it's quite hot out there, and when it's probably pretty horrible in spring here. But you might feel a part of your body to get heated up by the sun. Yeah. So what goes on when you're sitting in the sun and the sun's shining on a part of your body? It starts to feel. Well, this is what you might say. I'm saying this is actually not quite right. But what you might say is that part of your body feels warm. Yeah. So if you leave your arm out in the sun, it starts to feel warm. Yeah. What's going on there? That's the way we would characterise it. But I think, so from a first-person perspective, it'll seem to feel hot, warm or hot, something like that. Let's just leave it at that. Let's not worry about sunburn and pain and all that kind of stuff. This is complicated enough. But what you might do, interestingly, is you might, if you touch a part of your body which feels to you to be warm, or even if you get close enough to it, it'll make that part of your body feel warm too. And I think, this is from my first personal experience, that the kinds of sensations don't seem to be very different. It doesn't seem to be the case that when you're having what might be called a perceiving sensation and an intrinsic sensation, that they seem to be different in quality. And I think that strikes me as a problem for BC, because he thinks there are these two kinds of sensations, but it doesn't seem to be right. So try it. When you're sitting out in the sun next time, hand feels warm. Put your other hand close to it. That hand will also seem to feel warm. And in fact, when you touch the other hand, that hand will seem even warmer. But I don't think these are different sensations here. It's all the same kind of heat sensation or warm sensation, the same kind of feeling. So I think he has a problem in that thing. This is actually a minor problem as far as I'm concerned. I think there's a bigger one. Problem for Armstrong? Well, his theory says that what goes on when we touch something and it feels to be cold to me, but something could feel to be warm, is that you're detecting or representing a difference in heat between yourself and the object. Well, I'm not sure how that could work, because in order to detect a difference, you would have to detect the heat of both things. It's not clear to me if that's right, then it seems to me that what's really going on when you touch an object and feel whether it's hot or cold, the immediate object of perception is some property of the object, not a difference between the two. So this is just a gesture towards my not really being able to follow what Armstrong's claim of when you feel something to be hot or cold, you're detecting a difference in temperature. So I'm not sure how that works, but I think there are bigger problems. This is the one this is the more general challenge, and it goes something like this. So if you are like these guys, and you think that when you're having a heat or cold sensation, you're representing a property of objects, you have to tell me what that property is. It's all right. You might say, oh no, it's just hotness or coldness. Yeah. So, I'm detecting the coldness of that. I'm detecting the hotness of that. Right. So what is that? What is coldness and hotness that you're representing? I want an explanation of what that is. So the onus is on those people who argue that what's going on when you detect a property of objects, when you have heat sensations and cold sensations, is to tell me exactly what that property is. It's not enough just to say hotness or coldness, because that doesn't really get us very far. So I want to suggest that it's not clear what properties of objects could satisfy that. So here's the thought. If heat and cold sensations represent properties of objects, in the way that my visual experience represents the redness of that, yeah, I want to know what that property is. I mean, people have got a good story about what redness is. It's reflectance. It's a surface reflectance property. It's the wavelength of light that gets reflected off an object. That's what's detected by your visual systems. Yeah? Does that make sense? I don't know how... that's a very popular view. So what your visual system is really doing is picking up on reflectance properties. There's a different one, nice blue over there, so it's detecting a different reflectance. Detecting a different reflectance here. That's what colours are. So what I need to know is what hotness and coldness is, if it's the case that our heat and cold sensations represent those properties in the way that other perceptual modalities do. And it's not clear what properties they could represent. You know, what I'm going to go through is a couple of options and kind of try and give some considerations to thinking that these won't work. It looks like it probably could be reflectance properties, because whenever you have a certain kind of red experience, the object has a certain tendency to reflect those wavelengths of light. That's why people tend to think it's an reflectance property. But it's also clear what it is in the case of heat and cold. So here's my question, and you can knock down my paper if you can come up with a property that you think heat and cold sensations could represent. This is your point. Right, that's where it would go. I mean, what I'm saying here is, I can't think what they are. So I'll go through a few, and we'll see if you can come up with anything else. I mean, I'll go through what I take to be the obvious ones. So I think the obvious place to look is physical properties. What could these physical properties of things be that's represented by heat and cold sensations? We know what it is in the case of colours. We've got a good story there. We've probably got a pretty good story in the case of sounds. What do you think's going on there? It looks like auditory experiences. We're representing sound waves, something like that. Okay, maybe they're competing stories. So what I'm asking is, what's going to be going on in the case of heat or cold sensations? What could those physical properties that might be candidate representational contents? I think there are a couple of obvious ones. I don't think either of these will do. Okay, so what do? We probably look at thermodynamics. I'm not going to get too complicated here. But there seem to be two properties, and I think this is what people do say, which is interesting, and I think they're just wrong. I'd like to know why they say that. I mean, if you were to think of a couple of things that might be detected by heat perception, what might you say?
Thermal energy.
Right, I didn't think you would say that, but it could be. That's good. That probably is one. Anything else?
Vibration of molecules.
Right, because that is.
The average kinetic energy of particles in the object is the temperature in physics.
Something like that? Good. Right. That seemed to me the obvious possibilities. So thermal energy. Right. God, my students wouldn't say this. And temperature. That sounds about right. And don't you hear that? Ooh, I can feel the temperature of that when it feels hot or when it feels cold. So I think people immediately say, ooh, it's the temperature that we're sensing, that we're detecting. So, question. That would be the plausible suggestions that you might have for heat perception, analogous to surface reflectance properties in the case of colours. That's how it might go. What I'm going to say is, no, I don't think that can be right in this case. And here's why. Let me just, obviously you know this, but I think it's significant. So we do draw this distinction between thermal energy and temperature. Why? Because it's significant in thermodynamics that thermal energy is passed between bodies according to their temperatures. I think that's probably distinct too from what goes on in other forms of perception, and has to be captured. So it's important that it's the temperature of the system that determines in which direction the energy goes. So if the body is at a greater temperature, the energy is going to go in that way, and vice versa. I think that's significant, and I think that's what's going to be part of the final story, the so-called heat exchange model. That's the idea. Makes sense so far. So here's and see if it's obvious. It seems obviously intuitively correct to me. And other people who've listened to the paper said, yeah, of course, that's right, can't be that. And others have kind of thought, hang on, what's going on here? So see if you can get this, and tell me if you think it's right. Well, I hope it is, because the reviewer hasn't said anything bad about it. But So look, here's my example to think about. So if you start off with something cold, right? What I mean here is it feels cold, right? And thermal energy is transmitted to it. It will increase in the amount of thermal energy it's got or the temperature it has. But and it will increase uniformly in a single direction. So if you like, you could plot it on a graph. Ooh. So the more energy you feed into the system, the cold object, the greater its temperature will be, the greater its thermal energy will be, and it'll increase in a uniform way. That makes sense? I think that's right. You do your physics experiment at school or whatever it is, and they tell you to heat it up and increase the temperature, increase the thermal energy. But what I'm interested in is what is the way this is manifested in the kinds of experiences you have. What I suggest goes on is this. First off, when something cold increases in temperature, it's not experienced as it's changing in a single direction, which seems to be uniformly increasing in a certain way. What first happens is it starts to feel less cold, then kind of cool, then neither hot nor cold, then a little bit hot, then more hot and more hot. So it doesn't look like it increases in a single direction. It gets cooler and then it gets warmer. So it looks like is that a nod? Does that make sense?
Yeah.
I mean that genuinely, because I think it's obvious that there's this line of argument that can be taken against the view that what we're doing is detecting an increase in temperature. Or at least that the experiences don't seem to be directly tracking something that's increasing. What seems to be going on is that the sensations seem to diminish, the cold sensations seem to diminish, then the hot sensations seem to get greater. Now, if what's going on is you're detecting or tracking the increase in temperature, you would have thought it wouldn't be like that. That's my suggestion. Here's a comparison to see whether it works. Yeah, sure.
Can I add a small point?
Yeah, of course.
To the best of my knowledge, humans have heat and cold receptors.
We're getting to that.
Okay. So, as I was saying, yeah, it makes sense in the light of that.
It makes it right. So the two questions. That explains why it's manifested in that way, but we still want to know what's being represented by them.
Okay.
Right. So right. Yeah. Correct. Yeah. So look, here's a comparison to see if this makes sense, and I'd be interested to see if so far there may be people who might have a response, but it doesn't seem to be crazy so far, does it? So look, here's the grayscale. Are we familiar with what the grayscale is? It kind of, hopefully you can see. There's a kind of, it changes gradually, gets more and more bright, or it gets less and less dark, but in a continual fashion. So there's, as it were, just noticeable differences between them. Right? That's what I expect would happen if perceptual modality was representing something that increased or decreased in value in a continuous way. So how might you explain what's going on in the grayscale? Well, by the different quantities of light that's being reflected here. Not a lot here, a bit more 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 here, but quite a lot here. That explains the grayscale. Your experiences of these shades of grey can be explained in terms of the amount of light that's being reflected or received. That's what I think you'd expect it to be like if your thermal system was detecting temperatures, that it would increase in this kind of way. That's, I think, but that doesn't seem to be how it goes. How it seems to go is, I think, again, I'm not sure whether this is it seems to be like this. So you get maximum cold, diminishes to minimum cold, minimum hot and then maximum hot. That's how the kind of scale might go when you have an increasing temperature or increasing thermal energy. But just to go back, it doesn't look like that's what's going on here. I mean, here you don't get a kind of decreasing to here, and then you increase in another respect. So you don't get decreasing darkness and then increasing brightness in the way that if you do this kind of heating up of something, you get a decrease in coldness and increase in hotness. You just get a continual increase of brightness or a continual decrease of darkness. And that's what I'm suggesting would be going on if your heat sensors detected temperatures, the increase of temperature or decrease of temperature. So I think that's one reason why I don't think it's properties of objects. In particular, it's not temperatures, specific temperatures that's being represented by your heat and cold sensations. Make sense? So you might think, okay, so what other options are there? So let's just go through these quickly, because I probably should say more than that. You might say, well, actually, okay, so it's not this one property, temperature, that's being represented. It might be two kinds of things. So coldness might be representing one kind of thing, and hotness, feelings of hotness, might be representing another kind of property of things. But again, I don't know what it couldn't be. It doesn't seem to be plausible as temperature. The same kind of argument I've given here. But you might do a kind of do a Lockean move. You might say, oh, what's really going on is that our cold sensations are representing some kind of mind-dependent property. A property that something has that produces cold sensations in us. Or hot sensations might represent a mind-dependent property in objects. So the property that objects have to produce those hot sensations in us. So that's how it might go. So this would be question. Is this what's going on when you're having a heat sensation or a cold sensation? It doesn't look like you're representing temperatures for the reason I've given before. And I'll come back with respect to what you... so for something to be hot or cold to any degree is for it to be disposed. It's a dispositional theory, mind-dependent theory. Disposed to cause heat and cold sensations of a certain intensity. Is that what's going on? So when you're having when something is hot, it's disposed to cause a certain sensation in you. And when you have that sensation, you're representing that the object is disposed to cause that sensation in you. That sounds a bit circular to me. In fact, I think it is circular. I think that's a problem. So if you did adopt that view, you wouldn't have the previous problem that I had. So when something feels cold, it's because it's disposed to produce a certain feeling in you, and that feeling that's causing you represents that property that is a dispositional property. So it wouldn't face the previous challenge. But I think this has a problem because the only explanatory power that this account has is gained by building into those dispositional properties the exact features of hot and cold sensations that need explaining. And I don't think that is a proper explanation. I mean, another worry is you can't relate this up to all the facts that we know about thermodynamics that seem relevant here. So I don't think that works. Here's another one. That's a pure dispositional view. You might say, oh no. You might do the Lockean move. What's really going on here is that hotness and coldness of things are those physical properties, those physical grounds that cause dispositions in us. So then you have to ask, right, so what are those physical grounds that the heat and cold sensations kind of bring together? Because those properties, diverse properties, cause these sensations. So it's in virtue of their causing these sensations that you categorise them together as hotness and coldness. Well, I just think there's a problem here, and maybe I don't say enough about this, but here's the problem. Qualitatively identical heat and cold sensations, you've probably heard about this in the case of colour. So the same colour experiences can be caused by very different things. Exactly the same happens in the case of heat and cold. Heat sensations can be caused in very different ways. and there's a reason for this. It's because things having different temperatures can have different conductivities, and that's why they might feel the same. So you have to say, well, hang on, cold sensations can be caused by things which have different temperatures and different conductivities. Does it sound plausible that those kind of complex, disjunctive properties are what you're representing when you have a heat or cold sensation? Doesn't seem to me a very, very plausible move. So I put it this way, don't worry too much about that, because I've got a much simpler theory for what's going on. And it may be in the end that the advantage of my theory is that it is simpler than having something kind of very complicated like a Lockean story. What about this one? I think this might sound quite plausible. Something's hot, and why don't we say this? You know, when do you call something hot or cold? I think there are two criteria for this. One of them is because they cause certain experiences in you. So I would say that's hot because it feels a certain way. That's what I just considered. But I think the other thing that you might say is you might think of something as hot because it's hotter than you, and that is to say because it has a greater temperature than you. Or similarly, you might call something cold because it has a lesser temperature than you. So what about that? Could you come up with an account of what's going on when you have heat and cold sensations that might be explained in that way? I think this is quite promising actually, but I don't think it goes the whole way. So the idea would be that something is hot when it's hotter at a greater temperature than you, something's cold if it's colder, lesser temperature than you, and that's what's being represented when you have heat and cold sensations. So when you feel something to be cold, it is at a lesser temperature than you, that's what we mean by cold, and you are representing it to be at a lesser temperature than you. This is slightly different from the Armstrong view. And similarly, when you feel something to be hot, what you're doing is you're representing that it's at a greater temperature than you. The trouble with this view is that it's not able to explain what's going on when you feel your foot cold to be cold, or your arm to be warm, because there is nothing there that it's hotter or colder than that's relevant. So I think this account, the physical, what I call the physical relational property, the idea is that something has a property with respect to you, the perceiver, and it's physical relational, so it's at a greater temperature. That's the one. But I don't think this can explain how what's going on when your hand feels cold or your foot feels cold. Yeah.
Can't it be hotter or colder than the rest of your body? So obviously, if your hand is cold, you're feeling that because the rest of your body isn't as cold as your hand.
That's interesting.
Because that seems like, because you said before
Right.
that if it was cold to you because you're hotter than it, so your hand is kind of like a part of your body and the rest of your body feels hotter or colder.
That's an interesting one. I'll have to think about that. I have an idea someone did mention that to me, and I just didn't quite see how that could work, because you'd have to be detecting that is hotter than that. So right, interesting. I'll think about that one more.
But what if you have a fever, like your whole body is really hot,
Right.
and then you think, or you think like your head is colder than anything else.
Mm.
So like, not necessarily just your head is hot or something. It's also related to I don't know what else, but.
Mm. I mean, that's the same line of argument, isn't it? Right.
You can feel, you were saying before, you can feel in all different parts of your body. So.
Right. Interesting.
No, it goes in another direction, doesn't it? Like your head is maybe hotter than everything else, but still.
When you're having a fever.
Yeah, but still you think it's cold. It's colder than anything else in your body.
Right. Okay. I think that's a different case, because maybe so is the idea there that it feels hotter to you, but it isn't.
Or the other way around.
or the other way around.
It's
So it
hotter,
feels,
but it-
so it is hotter, but it feels colder.
yeah.
Of cold
Right.
sweat, I think.
Yeah.
Right. That's slightly different case here. That indicates that what's going on perhaps is that it is representational, but you're just misrepresenting things in some respect. But I'm not sure because you think it's a certain way, you feel it to be a certain way, yet it's not that way when detected in another way, by another means. So you're representing it to be in a certain way, but it's not that way. That's different from this case, where you're feeling your hand to be warm, and I'm saying that there isn't anything that, in the case of when you're feeling something else to be warm, that thing is at a hotter temperature than the other thing, and it's that explains what's going on. In this case, it seems to be different because there isn't anything else. So you were saying, oh yes, the other thing that it could be is another part of your body. I intuitively don't think it works, but I don't have a really good explanation for why. I will have to think about that one for why it doesn't.
But how would you feel if it was hotter, or how would you feel if your hand was hotter or colder if the rest of your body wasn't one or the other? It doesn't seem intuitive to me that you could
Well, sure,
detect
couldn't you?
any body part being separate from the rest of your body if it was
Right. But couldn't you feel in a tactile way some object or something? No, that's not going to work because that's. I have my story which explains this, because what's going on there is you are detecting the energy transferred to your part of your body. That's what explains the difference. But I'm not sure that I'll have to think about that one. Intuitively, I don't think it can be right that you can explain away how part of your body feels in this way, hot or cold, by comparison to another part of your body. But I'll have to think a bit more about that one. So anyway, look here. So that's my negative bit. It's not clear to me that the heat or cold sensations represent properties of things, whether they're properties of other objects or properties of one's own body, because of these kinds of arguments. The one about temperature and the others. So this is what I do think is going on. I mean, here's where you may end up, and this is where people have ended up in the literature. What little of it there is to say, actually, okay, so I can see now how hard it is to find a property like surface reflectance or sounds that are the properties of things that are represented by experiences, in the case of heat and cold sensations. And some people have argued either that heat and cold sensations are in error in some respect. They tell you that things are hot or cold, but there is nothing corresponding to hotness and coldness. Or the other theory is kind of anti-representationist or non-representationist. What they do, what heat and cold sensations do, is inform us about the presence of thermal events only insofar as they're relevant to our well-being. So they don't represent any features of things, except insofar as their potential relevance to us. I actually think that there's something that's right about this, but there's no reason to think this is non-representational, because what I think they represent are this input and output of energy to us. And that is certainly of relevance to us. I think that's what's represented. Yeah.
Could you say that they are properties, but they're response-dependent properties? And that the properties are exhausted by saying that they're disclosed to create a certain experience?
Well, I don't think that works for the reason that I gave earlier, those two anti-dispositional ones. But this is the bit that I'm wondering whether I haven't thought through enough. Right, so, I presume response-dependent properties are kind of dispositional properties, dispositions to produce experiences in you.
Yeah.
But I just don't, for the reasons that I gave before, they're either going to be pure response-dependent properties, that is to say, cashed out purely in terms of the responses they cause in you, or the physical grounds of those properties. And I think there are worries in either of those. I would be interested to see if this gets published and if anyone takes any interest in it, how these things go, whether people will come up with those kinds of responses and say, no, that's really what's really going on. Because then it'll just be about competing ones. I think mine is kind of pretty good because it's consistent with all the data without having to bring in these response-dependent properties and things like that. That's the way I'm going. So here's the your bit, right? You're dead right. We have in our skin there we have hot and cold receptors, which explains the data. So it explains why. So this is why I'm glad because I'm gonna. It makes it life easier for me. What I put here is neural activity and temperature. So we do have cold receptors and heat and hot receptors. So we have two kinds of receptors in our skin. You probably know all of this stuff, but I think it's so. And we also have what's called a normal range or a neutral range. It's somewhere between 30 and 40, and at that range you don't feel either hot or cold, and that's the state that we're typically in. It's kind of normal temperature. But when things get cold, or you touch something that's at a lower temperature, the cold receptors kick in. They fire, and they show this kind of bell curve. So there's a maximum activity between about 20 and 30. And the hot receptors do something similar, but when the temperature increases, and it's a slightly different shape, which is interesting and probably significant. But the maximum activity is about 40, 42. So the evidence of when we feel hot and cold sensations can map against body temperature, rather than temperatures of other things. But this is mapped against body temperature. So you get cold sensations when your skin falls, or falls within this range. Hot sensations when your skin increases to that range. So here's the question. That's the data. That's the stuff you were pointing out. That explains the physiology behind our heat sensations and cold sensations. But what I want to know, and then this is a question of so Ben, that's the science. Now we're doing the philosophy. Because when I gave this paper in Crete, there was a professor of neuro whatever. And he said, no, it happens like this, happens like this. I said, no, right, that's how you test these things. You plot it against skin temperature. But does that mean that that's what these receptors are detecting? Is that what they're representing? Because there are other things that they also co-vary with. And I'll just point them out. So that's your receptor activity, yeah? The question is, okay, receptor activity varies as a function of skin temperature, but is that what that receptor activity, which is correlated with feelings of hotness and coldness, yeah, heat and cold sensations. What I want to know is, does that mean that it's detected or represented by those sensations? What I want to say is no, it's not, and I'll give you further reasons for thinking this. So here's the thought. While the responses of these are measured by reference to temperature, that's why the guy said, no, they represent skin temperature, because that's how we measure them. I don't think we should jump to the conclusion that that's what their function is, to detect skin temperature, because there are other things that it could also be detecting. That's my line of argument. So why? They causally correlate. This is one way in which you might understand this job of detecting, indicating, causally correlating with. Does that make sense? So these detect something or represent something, these sensors or receptors and the experiences that we have when they fire, because they causally co-vary with these features. That's why we might talk in terms of detecting or representing. Yeah, you might have got that in philosophy of perception. You certainly will do if you do a philosophy of perception course. But there are two other features that they causally co-vary with. They causally co-vary with the change of temperature. So they fire not merely when the skin is in a certain temperature, but when there's a difference. So when the temperature decreases to that, so when there's a change in temperature in that direction, similarly when there's a change in temperature in that direction, that's what they co-vary with also. But there's a third thing that they also co-vary, and that's with the amount of thermal energy input and output to the system. So when there's thermal energy input to the system, those will start to fire. Obviously, because the temperature of the skin increases. Similarly, when there's loss of thermal energy, the skin temperature will decrease and that will fire too. So the firing of the receptors and the consequent experience, sorry, I shouldn't keep pointing at you, you raised it. Very, you've all done exactly the right things in the right moments, which is very gratifying for me. But, so the point is, the data that we get from physiology and the science tell us that there are three things that these receptors in our skin, and hence hot and cold sensations, co-vary with. They co-vary with the temperature of the skin, they co-vary with the change of temperature from the skin from normal, and they change in relation to the amount of thermal energy that comes in and out of the body. So there are three things that they causally co-vary with. Hence, those are three features, and they're not, well, one of them's a property of an object. In fact, probably two of them are properties, and it's a property of the skin. It's a property of your body, not of other things. But there's a third one. There's the input and output, and that's the one I think is what's actually being detected. That's what I think it's the function or the design of the system to monitor, the input and output of energy. And here's why. There's a little bit of extra stuff that you may not know, which I think is which is the only reason I could write this paper, because it's the interesting bit of data that I think might tell. But here's one thought. So when your skin is at 40, feeling hot, why should it feel the opposite of feeling when it feels cold at 20? So it looks like, when skin feels cold, it's the opposite of feeling hot. Why should that be the case if you're just representing degrees of temperature? It's not so clear. But it does make sense if that pattern of sensations, hotness and coldness, more and less hot and cold in those directions. Because remember, so it gets more and more cold that way, or it feels more and more cold, but it feels more and more hot that way. That might be well explained in these two ways, that what you're doing is you're representing changes of temperature in different directions, and more and less of it. Or amounts of thermal energy being lost or being gained, more or less of it. So when your skin feels really quite warm, it means quite a lot of quite a lot of thermal energy is being input to the system. When the skin feels really cold, it means quite a lot of thermal energy is being lost. That's the way I'm going to go. But at the moment it's neutral between those two, I think. So here's the bit of evidence that I think tells on this. Further facts. So some further facts that you might not know about. I'd be interested to know whether you do. So look, it's an interesting fact that when an increased area of the skin is heated up, so rather than just heat up well, you do it on a part of your body. So rather than heat just here, you heat a lot more of the skin. So when an increased area of the skin is heated or cooled, there seems to be a perception of increase in heat or cold sensations, not of overall area of the skin, which is interesting. So, does that make sense? Right. So here's how it goes. So what would you expect to happen if rather than heat just this part of the body, you stimulated a bigger area of the skin? You'd have thought more of the skin would feel the same way. Yeah? But apparently that's not what happens. What happens is that you feel an increase in hotness, not an increase of the skin more generally.
But only if you've started with a smaller...
Right. That's the way it seems to be going. Yeah. So there seems to be a way in which when more of the skin is stimulated, either with a heat sensation or cold sensation, rather than it feeling to you like there's more of the skin being heated or cooled, you get a feeling of greater heat or coldness. That occurs quite a lot. Obviously not all the time, but there is this phenomenon whereby, and this is the important point, the phenomenon. This is the idea that thresholds at which heat and cold sensations are felt can be maintained at a constant level by doubling the area and halving the intensity, which is kind of interesting, because if that's right, then it looks like what our thermal system is doing is not measuring absolute temperature or even changes of temperature. It seems to be detecting something else. So this is the other way of putting it. Warm and cold receptors can generate heat or cold sensations of the same intensity when the skin has different temperatures if a greater area that's stimulated, which kind of indicates that it's not the temperature of the skin that is really what the heat system is, heat receptor system is tracking. It's something else. And what I think this indicates that it's tracking is the energy that's being input. Because why, if you increase the area of the skin being stimulated, but don't increase the temperature of the skin, and yet it feels hotter, what is changing then? It's the amount of energy being put into the system. So I think what this does show is this, and this is the kind of reason why I think in the end this is what's going on. That what heat sensations do, when we have heat sensations, right, there's all this physiology going on, these receptors firing, but what they're co-varying with, what they're detecting, what they seem to be picking up on is the amount of energy coming into the system, coming into the body, or leaving the body. That's why I think it's these features that are being detected by heat sensations and cold sensations. So I think these together constitute the heat detection system, but what they're detecting is the heat exchange, the heat that's coming in and going out. That's the idea. Yeah.
Another quick question.
Yeah, sure.
If you have a constant amount of thermal energy and you concentrate it on like sort of 1 square inch of body, surely you'll feel a different heat sensation than if you have that same amount of energy transferred over a much wider area of the body. So you're not really, in that case, you're not detecting the thermal energy, because there's two cases with identical thermal energy being transferred into the body.
Right.
Different sensations.
So what you're saying is that there's the same amount of thermal energy in both those cases, but they're different sensations. Right. I mean, I think, right. But why can't it still, right, I guess, so the thought is, here is a case just like before, where before I argued that there's the same temperature of the skin, but there are different heat sensations, but there are different amounts of thermal energy being input to the system. So you're saying that this is a case in which there are different heat sensations, but there's the same amount of thermal energy input. I'll have to think about exactly how that one goes. Can I think about it more slowly later?
Yeah.
So you're saying by hypothesis it could be the case that exactly the same amount of thermal energy is input. Because I'm just thinking, in the case of where you have a very focused stimulus that's very hot, it will feel hot. Whereas you're saying if that thermal energy, the same amount of thermal energy, is distributed over the body, it will feel a different way.
Yeah. I
Right.
think that's the case, I'm not sure, but I'm guessing it like a needle, like
Right, yes.
point of loads of energy is still different than the same
Right.
amount of
So, I mean, right, so what some people who have read this have said, so that seems to indicate that it's not just thermal energy, it's some kind of flux feature.
might be flat.
Right, that's what people have argued. I'm being a little bit vague on this. Right, and maybe I'd have to tighten it up a bit for it to work. It looks like, I mean, it could well be something like flux, and that would be plausible. I don't think it would be, so it would be energy input over an area. I'm taking that to be flux, is that right? We're happy enough with that. Yeah, it may be something like that. But I don't think that would be in the spirit of this model. It wouldn't be the precise, it would be in the spirit. Yeah, right, people have challenged that one. But I don't know that would completely undermine it, it would just need certain, I don't know, I haven't thought it through. So that's the kind of model. So let me just have some, sorry, I will wrap up. But we've had a few questions anyway, and I don't expect there'll be. So here's my thoughts, just more general thoughts about how this goes. So the heat exchange model, I take it. So the two other models that we had were the VC one and the Armstrong one, the one in which you've got these two kinds of perceptions of intrinsic sensations, or rather an account of bodily sensations, an account of feeling the heat or cold or something. What I think my account does, it gives a slightly different explanation of the content in terms of the exchange of energy, whereas those accounts talk in terms of properties of things. But I also think it differs insofar as it gives the same account, or it should give the same account for all of these kinds of sensations. That maybe that's where it may have slight rough edges. We'll have to see. So exactly how. So then I've got to say. So how what's going on in the case of feeling something to be hot or cold and feeling a part of your body to be hot or cold? I think it's the same thing. Sorry, I'm not sure that makes sense. What it should be is, right, so if in the case of when we feel a part of our body to be hot or cold, we're detecting the energy input or output from the body, what's going on when we feel objects to be hot or cold? Because it seems to be a different kind of experience. I think exactly the same kind of thing is going on with respect to the heat sensations. So when we feel an object to be hot or cold, what we're doing is detecting the heat that's exchanged between us and the object. That's what's being detected. So then the question is, what is the difference? What makes it seem to us that we're experiencing an object to be hot or cold and experiencing ourselves to be hot or cold in the other case? What makes the difference between the two? So if I'm right, and you all kind of nodded your heads when you said, yes, it's possible for my hand to feel hot or cold, my foot to feel hot or cold, but it's also possible for an object to feel hot or cold. Yeah? Is that right? So what explains that difference? What's going on there? Well, I think what's going on there is this. Is there a necessary condition for something seeming to be hot or cold? But remember, I don't think that actually we are representing properties of things. One has to touch it. There has to be an accompanying tactile sensation. So why an object feels to be hot is because there are tactile experiences as well. It's because there are tactile experiences that it seems to us that it's the object that's hot or cold. But that's not what's actually going on. What I think is going on is we're representing this input, this exchange of energy. So I think that's the way to explain the two. So more specifically, it's the presence, it's the co-presence, simultaneous and coextensive, tactile experiences and thermal experiences that make us think that it's the object that feels hot or cold. Gives us the impression that it's the object that feels hot or cold. But if I'm right, if the model and the reasoning behind it is right, that's not what we actually detect in our experiences. That's just how things seem to us. And similarly, when thermal stimuli are unaccompanied, we think it's a part of our body that feels hot or cold, not some object. So it's the tactile sensations that make the difference between something else seeming to be hot or cold and ourselves seeming to be hot or cold. But in both cases, what I think is going on when they're heat and cold sensations is this exchange of energy, rather than a property either of you or the object being detected. And that's why we think things are hot or cold. And we do, don't we? You think when you pick up your cup of coffee tomorrow morning, oh God, I'm going into a philosophy lecture. Don't we all think that? And you feel the cup to be warm. That's because there's a thermal sensation, a tactile sensation, that are simultaneous and coextensive, give you the impression that the heat belongs to the object. And therefore you think the object, you believe that things can be hot or cold. And I think that's the kind of story that we give about the content of our beliefs, about things being hot or cold. But I think that's a different story from the content of our experiences as of heat sensations and cold sensations. Just a couple of things, because I think this is, and then we finish. What does this tell us about the relationship between heat perception and touch? Okay, so big question that I guess I've done a bit of stuff on. How many senses do you think there are? 5. Yeah, that's the answer, isn't it? That's the commonsensical answer. So what?
Hearing, seeing, smelling, tasting, touching.
Right. So heat perception is a part of touch. That's how the story goes. Yeah, I think this. I mean, I don't think that's the case. I think they're different kinds of senses. They work in different ways. But here's a way of thinking about it. So heat perception, here's a reason why I suspect people do think they're the same sense. Why they do conflate them is because heat perception, like touch, has a skin as its sensory organ. Yeah, so it's all the same kind. That might be the idea. They both involve bodily sensations. So touch, when you touch something, you have a bodily sensation. When you have a heat or cold sensation, it's a bodily sensation. Third reason, heat perception depends on our touching things in order for us to be able to tell whether things are hot or cold. That's another reason you might think heat perception is all a part of touch. Right? I think those are probably at the background of this here. But if what I'm saying is right, then there are reasons to challenge all of these. Or at least this is not a knockdown argument, it's just, look, hang on, are you really so sure we should think of them as the same senses, or the same sense? One, because heat perception and touch involve different receptors, right? And they work in very different ways. So that's part of this, what you might take into account. Tactile heat sensations have different contents, if I'm right. So it's right that when we touch something, we do sense tactile properties of the objects, its smoothness. But if I'm right, when we have the heat sensations, we are not detecting properties of the objects, rather we're detecting this exchange of energy. Right, I don't go for the response-dependent view here. Yeah. So I think that might make them different. So it's a reason to think that they're not the same senses, because they have different contents. They tell us about very different things. And touch is contingently related to heat sensations. No, it's not the case that in order to detect the heat of things we have to touch them. No, I mean we detect heat without touching things, without having tactile perceptions. So it's a mere, what I think is going on when you pick up your cup of coffee tomorrow morning, you think about this, it's not that, that's the way we find out the thermal properties of things. No, it just happens that to be the case that when you do pick them up, you have tactile sensations, but you also have thermal sensations, which you can have without touching things. And those thermal sensations you have when you pick up the coffee cup tells you that energy is being transmitted to your body. And when it gets really cold after an hour, it's being transmitted away from your body. That's the story that I want to have. So that's it. Thank you. Well, we have questions anyway.
Does anybody have any additional questions? Yeah.
Do you think that there's a relation between this transfer of energy and particular properties of objects?
So is this like the question here? Right. Yeah, I mean there must be, because energy is transferred to you when an object is at a greater temperature. So there must be some kind of relation there, I think. But it's not clear to me that it's a consistent enough relationship for us to say that heat sensations are about that property of the object. For instance, the sun can cause the same kind of heat sensation in me as a radiator over there.
But then they could have the same property.
Right, and that is some kind of complex.
Something to do. I mean,
and the thought is, it's going to be a really complicated story. Mine's much easier. Mine's much simpler. So in the end, it may be that what might motivate my story more than anything else, unless your worries that it doesn't seem to be really tracking that right. My story seems to be a simpler one, because it does seem to co-vary with the energy that's input to the system and output from the system. Easy, right? And there's good reasons for us to do this. There's good reasons for us to track those features of our environment. But I think we are still tracking them, rather than, really, are we really tracking some complex relational property of the sun and radiators when we have similar heat sensations? It seems to me we're tracking the same amount of energy that's coming from them. Oh, that's my story. Right. So in the end, in this paper, I think there are some negative arguments, but it's not clear to me that they're knockdown arguments. Someone could come back, and that's what I was kind of hoping they would do in the end, to try and, because no one's worked on this stuff, no one's given philosophical accounts of this. And these are philosophical accounts because they're a little bit more than the empirical data. They're kind of philosophical glosses on it. I guess so. I may respond to say, okay, maybe you can think of some very complex property, but is it really plausible that we're detecting that complex property rather than a much simpler one? I guess that's the way I would go. Yes, I don't know. I'm not in charge of.
So any further questions?
Yeah, there are quite a few.
I was wondering it's not really challenging any of this also, what would you say, if I would say that different humans have different ways of feeling hot and cold, and maybe that feeling is somehow related to the social?
The social?
Yeah, for instance, I don't know, here, I'm from Germany, and
right,
I would definitely say that the climate is kind of similar, but people are completely different engaged with the way just t-shirts go out 10 degrees and nobody cares really, whereas in Germany it wouldn't happen. So so you used to wear loads of stuff.
Yeah.
I don't know why.
Right.
So or people who go abroad for 10 years, they go to Morocco, and then they come back and they're constantly cold.
Right. I don't know the answer to that. Yeah, that seems that. I mean, I went into an office back in Cardiff today, and there were 3 people sitting there, and I said, well, what are you doing? I said, well, I'm going over to Bristol to the thing. One said, well, what's it about? I said, well, heat perception. And they said, oh, that's really interesting. She's always cold in this room. She's always hot in this room, and I'm kind of in between. I don't know whether that. I didn't know what to say. Okay. You have an extra heater. I don't know. I'm not sure how this impacts on this.
Could you interpret the experience, the transfer of energy differently? So there's the same amount of energy going in, across the room.
Or there's some kind of higher cognitive system that somehow affects the way that we monitor energy, perhaps.
Like a psychological factor which would account for when you go abroad.
Right. I mean,
you're affected differently to the locals.
Right. I mean, you know, is it the case that I'm sure there's research done that certain people respond to different colours, or maybe even certain nationalities respond to different colours in different ways. I don't know. I mean, I guess if you live in the jungle the whole time, when you only see greens and browns and whatevers, you might respond to colours in a different way than if you know, nowadays we have all, you know, a huge array of lovely different colours to look at, which we didn't have. I don't know, maybe there's a similar story there, I don't know, I'm not sure.
We should.
There's plenty of time.
Yeah.
Regarding the differences between people and temperature perception, I assume that could be down to simply habituation of your
Maybe.
senses in your skin. So if you're constantly exposed to something, you just learn not to respond to it.
Right.
So
it's a bit like suntan or something like that. If you're always out in the sun, you get a tan very easily. I don't know, something. Yeah. No, maybe it's not quite the same.
So it's not like hearing the train go past.
I see.
That kind of thing.
I see. But that could well be a higher cognitive or psychological.
It's psychological, but not necessarily high cognitive.
Right.
More a physiological one.
Mm-hmm.
Can I bring up another point?
Sure.
You speak about heat exchange, but I'm not entirely convinced about that. There isn't any effects of contrast in the whole business as well.
Okay.
In the sense that your feelings of temperature be down to your experiences that some of your senses are firing hot, say, if you want to touch like something hot, whilst the receptors next to the area of the hotness aren't firing hot.
Right.
So does that make sense on that?
Yeah, but what is it? Oh, I see. Oh, sorry, got it. So like visual experience. So there's visual detectors which fire turn on if there's a stimulus in a certain part of the visual field, and turn off if there's a stimulus in another part of the field. That kind of opponent stuff. Is that what you were thinking?
Not entirely.
Okay, so what is it? So the idea is that you can feel your hand hot.
Based on the contrast that your other parts of your body.
Oh, I see. But this is the point we had here.
Yes, that was in relation to your own body, but I think it applies also in relation to things external to your body.
Okay. Not sure that I quite get it.
Are you saying there's no energy transfer, or there doesn't have to be?
I see.
There doesn't have to be. There could be down solely to this, or alternatively both of them could be going at the same time of the thinking as well.
Yeah.
Like,
It's interesting.
I can't see a reason to prefer one account over the other.
Right. Okay, I get right.
Both accounts at the same time.
Does this involve some kind of? Is this a normal phenomenon? I mean, might I say that this is just something going wrong in the system? That typically what goes on is that it does detect this input and output, but sometimes the system goes wrong when there are these. Because I can't quite think of the case in my own experience. I'm not quite getting it, I think. Because so the idea is that a part of your body could feel a certain way without there being any exchange of energy, because another part of the body feels a certain way without that part of the body. There being any exchange of energy with that part of the body. I just can't think. Right, I know the scenario, but I can't think of how that would work. Why would one part of the body feel different from another part of the body if there isn't anything making it do so. I guess it's I'm not quite getting that bit.
This got my point. I'm actually not satisfied with this.
No, that's fine. I mean, that's philosophy. We do that all the time. I mean, proposals and...
I was just going to, I think...
I'm still worried about your point.
Just within your body, so if my hand feels hot,
Right.
hotter than the rest of my body,
Right.
is that because of...
Right. That's because either because you're in direct contact with something that's hotter than you, greater temperature. You picked up a hot cup or whatever, touched the hot stone, or because of something distally. So you've left your hand out on the balcony and it feels hot, and the rest of your body doesn't because that's not in the sunlight.
So would it be the same kind of thing if I was standing on the train platform or if I didn't have gloves on?
Yeah, right. But then they feel cold.
So then is that because the rest of my body is
It's not
retaining the
loose.
thermal energy?
Right, it's not loose. I mean, that's the kind of model I'm thinking of.
Okay.
And it's you feel that it's a part of your body that is cold, rather than it being anything else that feels cold. So in my view, you don't feel that it's the air that's cold. You feel it's your body that's cold here. That may be contentious. Some people have challenged that one. But when you touch something, that object feels cold. But I think exactly the same thing is going on there with respect to the thermal aspects of your experience. It's just when the tactile experiences are also occurring, your experience seems to you different where the thermal properties are situated. But does that seem right to you? When you feel something by touching it, it's the object that feels to be a certain way, hot or cold. But when you don't have that tactile experience, it's your part of your body that feels hot or cold. I mean, that's an issue about phenomenology. How does your experience seem to you? It seems to me that that's right. I mean, here's one. I mean, I've seen people write it when they pick up the coffee cup. It's not that you have a tactile. Someone actually wrote this, which was great for me. They said you don't actually have a tactile experience and an experience of coldness. They're all one experience. Actually, I think this is wrong phenomenologically. If you do it tomorrow morning, you pick up your cup of coffee. I reckon you will have a tactile sensation first, very quickly followed by a feeling of hotness or coldness, and that will seem a certain way. It'll increase in how you thought it would feel if you were detecting the energy coming into your body, phenomenologically, although maybe that's not a good argument. But think about it. They don't seem to go together. You seem to have, when you touch something, you get a tactile sensation first, and I've done it now. I mean, when I pick that up, immediate tactile sensation. Oh, now I'm just detecting.
But couldn't that just be down to the slow reaction?
Correct.
As they say,
Correct.
Put your hand on the hot thing, it is actually burning, but you
Correct.
don't feel it.
You're certainly correct about that. The reaction times are different.
So
you're right. What should one really read into this? It's not clear to me that one should read that much into it. Nevertheless, I don't think one should reciprocally or conversely, the fact that things seem to feel to you hot or cold shouldn't make you think that that's really what you're representing. That's the...
Yeah, maybe it's just sort of coming back to the points and maybe like...
Sorry, I'm sitting down because I'm feeling a bit tired.
It's like to the visual perception, so I'm taking it. The idea is we detect or transfer thermal energy.
That's the proposal.
And that thermal energy will be due to the thing at the temperature of the object, the distance it's from.
Right.
So yeah. So presumably you could argue silly for visual things. we're not detecting like the reflective properties. We can shine a red light on a white object. All we're detecting is different energies.
Some people have argued that.
And maybe it's
some people. That was what I said to begin with. Like, there may be some consequences for other. There are people who have proposed that what's going on is in visual experiences that we're something like this. It doesn't sound to me so plausible in visual experience. It sounds to me quite okay with this. So I don't know what that means. Should we expect to have the same kind of account for all the sensory modalities? I don't see why we should. But I mean, I just think this is one that people don't think about very much. You know, hardly at all. And in fact, when you do see it mentioned in papers, it's usually just very brief, a couple of lines. And invariably, I think they just get it wrong, or at least they don't think through the cases. Everything is vision, or a little bit of hearing nowadays, and a little bit of touch, but they just conflate the two, and I think that's questionable. I mean, that's what I'm trying to do here, just suggest that things aren't as straightforward as they seem.
Did you ever have a sensation when you had a temperature that your body feels normal?
Right.
And then, as your temperature starts dropping, you start feeling your body's hot.
Yeah, I mean, this is an example that's sometimes discussed. I mean, I think there are two things that maybe one should say here. What I'm really talking about in this context, so the obvious case is where you have a, that's when you have a cold sensation, and when your hand's in the sun, those ones. I think, and there is some evidence there are different thermal systems. There's one that detects your internal body temperature, and there's one that detects the temperature of the skin. Okay. I'm really interested in the latter. Whether they really are different, I'm not sure, or whether they've been conflated by some of the early accounts, I'm not sure. Right. So it seems clear that we do monitor our own body temperature.
Just in this case, you would be losing temperature,
right.
At the same time you're feeling actually hot.
Right. Those are tricky cases. Yeah. I mean, I might have to say something's gone wrong.
Okay.
You know, this is about representation. Representation assumes the possibility of misrepresentation. But yeah.
I think another of these examples of misrepresentation of heat is if you have like one hand in freezing water, one hand in
water. Sorry. I said that there were two. I think the more than one upshots. One of them is I think it makes us think about the relationship between heat perception and touch, and the other one was the Lockean case. So what's really going on there when you put your hand in the exactly as you described? So you've got the same bucket of tepid water. One hand has been in cold water or something like that, one in hot water. When you put them in two hands in the one bucket, they feel different. What's going on there? Well, most people think, they're misrepresenting in some respect. According to my theory, no, they're getting it right. One hand is actually taking in energy and the other one is not. That's why and that might be something in support of my way of thinking about it.
It's got a common problem in the research.
Right, yeah. Right, I mean, I don't know that a theory can answer everything. But I worry about your two cases. I'll think about it on the train back here.
One more thought.
Yeah.
Regarding the two buckets and
that's the lock case.
Okay. Does the same what happens if you have your hand like under the cold tap and then goes straight to under the hot tap and it doesn't feel hot?
Guess you're getting numb, so
okay, yeah, that works.
Say again.
It numbs the receptors. Or
Yeah, I think something like that does happen. There is a particular right. I didn't mention it. Was it problematic? But it does look like. Let me.
What happens on the receptors if the cold receptors are separate from the hot receptors?
So look, this was your case. So you mentioned that this is important. This is right. So I'm saying that the receptors behave in a certain way according to the temperature of the skin, right? So, and according to my theory, when energy is input to the body or skin, it'll decrease in temperature, hence they'll start to fire. But they'll indicate the decrease in temperature. But here's a worry that I have. So if you've got a better explanation, it might be the case that you can heat up the skin when it's really cold, and it doesn't immediately feel warm, as it should do on my account. It starts to feel less cold. That would seem to be really problematic for me, and that might be what you're driving at, those kinds of cases. So when your skin feels cold, so when you're standing on the station platform without your gloves on, and again, I'm not quite sure what happens here, but if you start to heat them up a little bit, it's not that they start to feel warm immediately, they start to feel less cold. Isn't that a problem for me? This is what someone said. Because what I'm saying is, whenever what the thermal system does, you get what I mean. It detects when energy is coming in or going out. But in this case, the energy is coming in, but it's making us feel less cold rather than warm. How do I explain that? I'm not quite sure. I think I have a problem there, some sort. I mean, I think I have to say that what's going on there is we're still detecting that energy that's lost, and less of it is lost now.
It seems to make sense to me. I don't see it as a problem.
Really?
Yeah, because I mean, I think it's because I don't really get the whole. There's a difference between cold and hot. I don't really think that. I think if you're like with the grayscale thing,
well, you
said it was like it can go more dark and then less light.
So you think
more dark and then more light. And then the same way that it just cold and hot are just either end of the spectrum.
Right. So you think that, I mean, this would be an interesting intuition. I mean, my view is that it's like this. It's at either end of the spectrum you have really cold and really hot, but you don't have an increase in hotness the whole way through, or a decrease in coldness the whole way through.
I think you do.
As you do on the grayscale, you have a decrease of coldness and then an increase of hotness. Right, that's interesting. That's really interesting.
From nothing, though.
Sorry?
You can't have an increase of hotness from from nothing.
Well, you do. This is the whole point. Because there's a neutral point, and that's what the receptors indicate. That a lot of the time we don't feel hot or cold.
So
and
that's
yet,
the body.
Right.
It's only for humans. It's only for living things. It's not a...
Why should that be? Because the issue is what our sensations are telling us about. So look. Here's because this is one where I am interested in the intuitions, because it seems to me that it's quite right here that what's going on is we're detecting that there is a scale here, less and less darkness, more and more brightness, and and it's continuous. But it's not clear to me that that's what's going on here. It's continuous. It seems to me that coldness gets less and less and less and less and less till nothing. And then hotness gets more and more and more. It's not that there's...
But if hotness and coldness are opposites in the same way that light and dark...
Right, that seems to be right.
Why can't you have a scale? I don't see how.
Are they really opposites then?
Yeah, I don't think they're opposite.
Right, that's an interesting point. So why do... Right, so it seems clear that... It seems clear that brightness and darkness are opposites.
And you have hotness and no hotness, or coldness and no coldness.
I think that may be the answer. That there are reasons for us thinking they're opposites. Because you put your hand in something, tepid water, you add hot to it, it goes one way, you add cold to it, it goes the other way. So that may give you the impression of opposites. But are they really opposites in the way that brightness and darkness are? I'm not sure.
Don't you need to believe that they are opposites because it's either energy transferring out or in, and that they're obviously opposed to each other?
Correct. Right. Do I have to believe that they're opposite? I believe. Right. I guess in that respect, in respect. Yes, I see what you mean. Yes. But they don't seem to be. Yeah. Clearly, you're right about that. If I hold this heat exchange model, that it's energy going in different directions, opposite directions, right? I believe that bit. But I think your question was more phenomenological one. Do they seem to you opposites? There is some sense in which one may think that they seem to you opposites, but is that correct? What makes you think they are opposites?
Because, well, what makes me think that they're opposites is that because I think of it as the scale.
Right.
So when I'm cold, I put more jumpers on and I go next to a radiator, which is going to make me warm. Right. And then if I stay there for too long, then I'll be too hot.
Right.
So
that's why you do think of them as that. Right. Yeah. Why do you not then?
I think I was confusing heat with cold then, the lack of heat, because I think actually that does work. The sensation, there's a middle point where there isn't a sensation, you're just neutral. But the sensation of coldness does increase as the temperature drops. But I think, and if you talk about lack of heat and heat, the heat is always increasing from there to there, the whole way from a scale.
Right.
But it isn't the hotness increasing. I don't think it's the sensation increasing. So I think I was thinking of heat and cold. When I said they're opposite, I don't think they're opposite, I think the sensations are opposite.
Right. There are further interesting questions there, I guess. Yeah.
But I don't really think that there's such thing as neutral. Like, you're always going to be a little bit too cold or a little bit too warm. Like, you just it might not be very noticeable. Like, you're just sitting there.
I mean, right. The neutral area. No, sorry. Wait. That bit.
Yeah, because it's not.
That bit is marked by a certain physiological reaction where the heat and cold sensors just fire indiscriminately. What happens when the skin temperature decreases is the cold receptors fire in an organised way, hot receptors fire in an organised way this way. Given that they fire in a fairly disorganised and constant way here, that's why we don't have any distinct experiences of hot or cold in that region. I mean, I'm not feeling either particularly hot, particularly cold at the moment. Kind of feeling pretty normal. I think, hopefully that's how things are most of the time. Unless there are specific occasions when, I guess.
Earlier you mentioned being at the bus stop and then going back inside.
Yeah, where was the number 9? I waited for 20 minutes for bloody number 9. Sorry. Not your fault.
You said you had concerns about that, right?
Going inside.
Or am I?
No, you could be. I mean, you know, when does anything work completely well? I mean, these objections are now worrying me because I haven't heard these ones before.
When you go back inside, did you say that you feel warm whilst at the same time feeling cold, or? I can't remember exactly your words, so...
I think you were saying that you feel less cold as opposed to...
Oh, sorry, no, that one.
Yes.
Right, sorry, yes. So this is the worry, this is the worry I have. Is it, on my view, the idea is that heat sensations represent energy transmitted to you.
Okay.
And cold sensations represent energy transmitted away from you. So you would have thought the converse would be the case too. Whenever energy is transmitted to you, you should have a heat sensation.
But you don't because you still feel cold, right?
Yes, or less cold. But you didn't think that was a worry, and I wanted to know why. That wasn't a worry. Oh, okay.
I was thinking, you're saying heat transferred to you and heat transferred away from you.
Yeah.
I know. Have you considered splitting the whole system up into by receptors, as heat transferred to hot receptors and heat transferred to cold receptors?
Right. But
something along.
But it's not. Is it not? It's not your eye that sees what's going on around you. It's you that see what's going on around you, isn't it?
Not sure what I am for a start.
Split the thing up.
I agree. I don't know what the self is. I haven't got a clue. I think that's a worry.
You could have split it up into two distinct senses where.
Right. So maybe this is the way one is going. So you have one kind of heat sense and another kind of heat sense. One's tracking the energy coming in and one's tracking the energy going out.
So
that may be right. Yeah. I mean, I'm assuming I'm kind of buying the story that we should think of them together. But it may be that's a mistake. That they just happen to. I mean, one of the reasons why you might think that they should be thought of together is because they do seem to be responding to the same thing, thermal energy, just going in different directions. And it does have something to do with temperatures. So, it would be like distinguishing, as some people do, a form of tactile perception when you touch something really softly and when you put more pressure on it. Because when that happens, different receptors are working. So, but I resist that as thinking of touch as coming in loads and loads of different flavours, if you like. Goodness, it's past 8 o'clock.
We've got like 10, 15 more minutes if anybody needs it. But if not, then we can conclude.
Have a quick beer before I struggle back on the number 9 bar.
I did just have a question about...
We're going out for a drink, though.
Yeah, do you know vaults?
Yeah. How far away is it? Will I be able
5
to?
minutes.
Will I be able to get back? Will I drown on the way back to the station?
Are you getting buses?
I don't know, because I don't trust buses.
Not in this weather.
Yeah, I just had a question about...
Yeah, go for it, yeah.
Do you want people to, ordinary people to change the way they talk about their...
No, I don't think so. Then why do you think you see something red before you, rather than, a certain kind of reflectance property, sort of around 490 nanometers. I wouldn't expect people to say that. People will still think of things as being hot or cold and make sense. But then the question might be, so what exactly are they meaning by that? I think one of them is that it's causing certain kinds of sensation in them. Then they'll think about what's causing that. Oh well, it's the fact that object is greater temperature. That's what they'll mean by hot and cold. There's no problem with that. All I'm thinking is that I've given a slightly different account of what I think is going on when we have these experiences. What those experiences are tracking is not in the first case, and in fact I don't think in any case, features of objects. It's features of the energy it is the energy that's being transmitted to and from.
But you don't dispute that the thing that causes these perceptions are properties of objects.
Correct.
Yeah, okay.
And hence that it makes sense to think your coffee cup is hot or cold. That's right. But I just don't think that it means that we have to think of our experiences as being about those. That's the move. Anyway, thank you.
Thanks very
Good
much.
questions. Really useful for me. Thanks for that.